Bismillahirrahmanirrahim. Hello students, how are you? I hope you have got enough information about process and thread on operating system. And if so, we can start and continue our discussion about migration, especially migration of process in distributed systems. What did you do? What did you do about process and thread in operating systems? Have you got enough information about it? Very good. I expect it for you. I expect you have searched enough and got some enough information about fundamental concept of process in operating systems. So tell me, what is process in operating system? What is process? Waiting for your reply. What is process? I asked you. Any execution. Yes, exactly. It's very simple. Easy peasy. It's so simple. In fact, everything that is currently under execution in operating system is called process. That's it. So an active program can be called a process. What is active program? When you program something in C++, your code, it is not active unless you run it, you compile and run it. Once you run your program, it is an active program and it can be called a process. That's it. So process is everything that is currently under execution in our computer or on processor. Each program that is under execution has some information. For example, local variables. Each program has local variables. So local variables is part of important data of processor. Each process has ID, has a name. So process ID and process name are other important information. Program counter or PC is another information each process has. Process state. Process can have different states during execution. For example, ready. If a process state is ready, it means it is waiting for processor to be executed. It is ready. Running is another state for processor. It means the process is under execution right now. So the state of the process is running. And terminated, blocked, asleep, wait and sleep. These are other states of process. So process state is another important information that each process must store it, must have it. And thread is a part of code. if we call the whole code, the entire code, as a process, the thread is a part of code. Okay, it's a light process. It is a light process. So with this basic and important information, we can say about process migration here. We can move an active process from one machine to another in distributed system. For example, suppose we have a process, an active program that is under execution on our local machine here. Our machine is a part of distributed system. We can move this process to another machine. Okay, it is called migration. It is called migration. The process migrates to a target machine or destination machine, transferring a sufficient amount of the state of a process from one machine to another. So we may need to transfer some important parts of process to another machine. A process with registers and flags and program counter and also some of other things can be moved to other machine. PCB or process control block. PCB. PCB is a table which has a set of process information including process name, parent name, children name, and process state, and also a stack if the process has a stack. What is a stack? For example, when you use some advanced data structure such as linked list, such as pointers, okay, such as trees in your program, linked list. If you use it, the program needs a stack to store, for example, calling address and what and where it should return, the return address. And so to move a process to another location, we firstly must create a process at our destination. So we firstly must create a new process at the target machine. Okay, and then we can move all the information of the process to the target machine. For example, we firstly make a new process in the target machine, and we have to create a PCB for it, and also some important information must be moved to the target. For example, a program counter and registers and local variables and anything that the process needs. So, got it? I suppose now it's easy for you to understand. So, yes. I repeat again, I summarize what I said. We have some processes in distributed systems running on some machines, okay? In some cases, we need to move this process from a machine to another machine. It is called migration. To migrate a process, we need firstly to create a new process at the target machine, and then we transfer all the necessary data of the process to the target. What are the necessary data? Process name, process parent, process children, and process ID, and local variables, and flags, registers, and anything other that is needed. Okay. So why migrate? Why do we need to migrate a process to another machine? Why? There are many reasons to migrate. There are many reasons to migrate. One reason is loading sharing, load sharing. Load sharing is a good reason to migrate a process. There are two concepts. One is load sharing and the other is load balancing. So do not confuse them. Load sharing and load balancing. Load sharing means we have to, or we want to share the load between some machines. But load balancing means we want to balance the load in the system, balance it, تعادل, balancing, okay? So load sharing is one reason. Load sharing means sharing the load between several processors or several machines. Load balancing means trying to balance the load of all processors or all machines. Load sharing means that when a processor is overloaded, it means when a processor or when a machine is too busy, it has many works to do, it is too busy, it's heavy. When a processor is overloaded and heavy, we may want to transfer some of that processor's work to another processor. In this work, we must pay attention to communication, because when we move a process, we have to move a lot of things. When we want to move a process, we have to move a lot of things. We must move part of or all of the PCB, process control block. So load sharing is a good reason for migration. Understand? What about other students? This chapter is very important, so please pay attention carefully. Balanced, yes. For example, you are executing too many applications on your machine, on your computer. Your CPU is too busy. So if we have some light machines here, some machines that do not have anything to do, do not have a job to do, okay? You can transfer some of your programs that are under execution. It is called process. You can move some of your processes to another machines. So you balance the computation here. موازنه، تعادل, okay? It is load balancing. Client and server, yes, for example. Or if we use P2P, peer-to-peer model, balance between nodes. Each node is a machine, okay? We try to balance load. What we mean by load is exactly about execution of process. Load balancing, load between the works of processors, machines. So, another reason may be communication. Why migrate? Because of communication. For example, please pay attention. For example, consider the data is on machine 1, okay? The data is stored on machine 1, and the process, the process is on another machine. So we pay huge cost here for communication because the process is executing on a machine and it needs the data. The data is on another machine. So communication is too high here, for example, if the process needs too much data. In this case, we can transfer the process to the machine on which the data is stored on. It is migration. We can transfer, we can move the process to the machine that the data is stored on. So the communication performance is increased. It is another reason for migration. Got it? Yes, exactly. Migrate the process to the location of data. With this operation, the process is near the data, so the communication is removed. But when we have a process in another machine, the process needs the data, so the communication is too high here. It has cost performance. To solve this problem, we can migrate the process to the location that the data is stored on. So it is another reason for migration. What about the result? The result must return. The result must return to source, to the source machine. To the source machine, because the process was executed on source machine. The operating system of the source machine needs the result. Okay, the operating system of the source machine needs the result. We transfer the process to the destination, but the result must return to the source. That's it. Is there any other reason? Let me look. Yes, availability. Availability is another reason for migration. Long-running processes may need to move because the machine it is running on will be down. Can anyone explain it? Can anyone explain this? Long-running process may need to move because the machine it is running on will be done. It is not absolutely about failing or crash. Consider this example. We have a server, okay. On this server, there are many processes. This process provides services for clients, okay. Now, suppose you want to overhaul this server. You want to overhaul. What does it mean, overhaul? Overhaul means quick. Overhaul, you have heard about it. Overhaul airplane, overhaul some devices, overhaul. Many repairs. For example, you need to repair your server. You need to check the server for viruses. Check with antivirus. So you need to stop the services of the server. So the server will be down for a while, for few hours, for example. Okay, for few hours it will be done. Why? Because you need to check all the hard disk of the server for finding viruses, or for overhaul, for making some repairs. Okay, so in this case we can transfer the processes of the server to another machine. So it helps us to make the system available, to hold the system available. Why? Because we have the processes. We move the processes to another machine and we repair the server. We can check the server for viruses or anything else. The processes are still running, so the availability is accessible here. Got it? Okay. The other reason is about utilizing special capabilities. Process can take advantage of unique hardware or software capabilities. Is it clear for you? Or you may need some more explanation about it. Utilizing special capabilities is another reason for migration. Process can take advantage of unique hardware or software capabilities. Suppose we have a process in our machine. It is responsible to calculate something, to solve a problem. Okay, the problem is heavy, the problem is big, and it needs large computation. we have another processors or a heavier processors on another machine in our distributed system. In this case, we can move the process from our machine to the powerful machine to complete their execution and return the result here. So, utilizing special capabilities can be another reason for migration. I mean, we may need something that we do not have it in our machine. We may need something that we don't have it on our machine. In this case, the process can migrate to other machine. Clear? Very good. So migration is very useful and very important in distributed system. It is a usual event. Migration is a very usual event in distributed system. It happens regularly. So who starts the migration? Who begins the migration? The user can start the migration, the client can start the migration. If our operating system would be smart, our operating system can start and initiate the migration. Process can initiate the migration too. I suppose it's very clear. So if we have a good operating system, it may begin the migration. The operating system knows that where is the device and move the process there. The operating system can detect that the load is too high. For example, the operating system can detect that the load is on our machine is too high, and then moves some processes to other machines for balancing the load. So the operating system or the process can start and initiate the migration. I think this chapter is very interesting, isn't it? Is it interesting for you too? Good. So what is migrated? What is migrated? I talked about it. I said that the process is like a tree. When we want to move a tree to another place, we must move everything, branches, leaves, roots, anything. So when we want to transfer a process to another location, we must move and transfer everything that is needed. Almost everything must be moved. That is, all things on source machine will be deleted and all things on the destination should be created. Process control block or PCB and any links must be moved. Process control block contains process name, process ID, process creation time, parent of the process, children of the process, local variables of the process, heap area of the process, and many things. Registers, flags, and any other things that the process needs. All these data must be moved. Must destroy the process on the source system. Why? Because there is a very important reason. Because each process must be under execution in one location only. We are not allowed to execute a same process on two locations. It may have some difficulties such as inconsistency, and we don't need it. So we must execute process only on one processor, not two machines. We are not allowed. Okay. So yes, to get one result, exactly. Methods of migrations. There are different methods to migrate a process. I can name some methods here, but there are too many methods. For example, combination of these two. So we start with either all. In either all method, we transfer entire address space. We transfer entire address space of the process. No trace of process is left behind on source machine. If address space is large and if the process does not need most of it, then this approach may be unnecessarily expensive. Why? Because we move everything in this method. I repeat it again. The first method of migration is either all. It's the name of this method. In this method, we transfer all things of the process. No trace of the process is left behind on source machine. That is, all things on source will be removed and will be created on the destination. With either all method, we firstly change the state of the process on source machine to wait or block or sleep. We must stop the process, okay, and then move it. So you know the state of the process: wait, ready, sleep, running, dead. Address space of a process contains, what is address space? We said that transfer entire address space. What is address space? Address space of a process contains PCB, process control block, with all its information and all the addresses that the process can access and many other things. In simple words, it means everything. Everything related to the process must be moved. So if the address space of the process is too large, for example, we have a process that has too many local variables, all the local variables must be moved here. So we have some difficulties in communication. It is expensive to move a large amount of data to migrate a process in this method. Got it? So the question is that Is there any other method that is not too expensive? We can say yes. Fortunately, we have other methods to migrate a process with no expensive communication cost. Okay. Yes, when our process is very small, and the address space is small, then this method can be useful. We can stop the process completely on source machine and move and transfer everything of the process to the destination. It means we create a new process on the destination machine and transfer all the necessary data to the destination machine. Very good, very good. The other method, pre-copy, it is called pre-copy. Pre-copy, process continues to execute on the source node while the address space is copied. It is pre-copy. I explain more, don't worry. Suppose we have a process in our local machine, okay? It is under execution. It is under execution. While it is under execution, we start to copy the data, all the data of the process to the destination machine. We do not have two processes at the same time. We have one process, but while the process is under execution, we start to copy all the necessary data and information to the destination machine. Then, when we finish our copying, we stop the process on source and we start the process on the destination. It is called pre-copy. Got it? Do you need to repeat it? Do you want I repeat it? Yes, of course. Assume we have a process running on our machine, okay? This process is under execution, okay? While it is under execution in our machine, we can start to copy the necessary data. For example, local variables, flags, registers, PCB. We can copy this information and this data to the destination machine. Then, when we finish our copying operation, when all things copied and transferred, all the data moved to the destination machine, we can stop the process on our machine and we can start the process on the destination. Yes, you can translate. If you want, you can translate to other students. Do you want me to start from the beginning of methods of migration? Okay. I suppose all the students have understood what is migration. Moving a process to another location. Okay, so we are talking about the methods of migrations. The first method is eager all. In eager all, we transfer entire address space. So we firstly stop the process. we firstly stop the process on the source machine, and then we move all the information and data that the process needs to the destination machine. And then we can start the process on the destination machine. It is called eager all. So you can translate.
Salam, doctor. How are you?
Salam, thank you. You can translate if you got.
Yes, doctor. السلام عليكم أساتذة. هنا الأستاذ دا يحكي على طرق الميجريشن، طرق مثل ما نقول المهاجرة أو نقل المعلومات مثل ما نقول أو processing. واحدة من الطرق اللي هي الإيجر أول. هاي الإيجر أول، هاي الطريقة شو تسوي؟ ينقل كل المعلومات اللي موجودة بالسورس. شنو هاي المعلومات؟ شو يسموها؟ الأدرس سبيس. الأدرس سبيس مال البروسيس شو يحتوي؟ يحتوي على البروسيس كنترول بوكس. البروسيس كنترول بوكس ايش بيه؟ بكل المعلومات مال البروسيس، من الاي دي، السي بي يو، ريجستر مالته، كل المعلومات مال البروسيس موجوده وين؟ بهذا البوكس اللي هو يسموه بروسيس كنترول بوكس. اوكي، اللي موجود بالادرس سبيس. فهاي العمليه تنقل كل هاي المعلومات، مو جزء من عندها، كلها تنقلها وين؟ تنقلها الانذر ماشين، نقدر نقول يعني شو اسمه ديستنيشن ثاني، وجهه ثانيه. اوكي، يعني الماكينه الثانيه مثل ما نقول. اوكي، حتى شنو؟ حتى يصير هناك، يصير المعالجه تصير هناك بالماشين الاخرى. ليش؟ طبعا لان هنا طبعا مرات يصير على البروسيسنج لود وما يتحمل يسوي معالجة لكل المعلومات وشي، فحتى نخفف عليه اللود شي يسوون الاميجريشن، فينقلوا الوجهة أخرى أو ماكينة ثانية أو جهاز ثاني حتى يصير بروسيسنج بيه. ورا ما تخلص عملية البروسيسنج بذاك الجهاز، طبعا البروسيسنج معناها معالجة، أوكي، بالجهاز الآخر أو الديستنيشن اللي قصدناها، وراها الريزولت وين راح ترجع؟ راح ترجع للسورس، للماكينة أو الماشينة الرئيسية. أوكي، ومن عندها تطلع. أوكي دكتور. I think now it's clear.
Thank you. Have you talked about the disadvantage of this method about large address space? And
yes, I talk about the address space and what the meaning of address space and what is inside it, and about the processing control box and what is inside the control processing box.
Thank you, thank you. Okay, the other method is pre-copy. Pre-copy method is in this way. While the process is under execution on client or on our machine, the process is under execution. We can make a copy of the necessary information, the PCB and other information that the process needs. We can make a copy to the destination while the process is under execution. Once our copying is finished, we can stop the process on the source machine and we can start it on destination machine. It is called pre-copy.
أساتذة الطريقة الثانية اللي هي مع الميجريشن اللي هي بري كوبي. البري كوبي هي كوبي، البري كوبي معناها شلون النسخ الأولي أو يعني ينسخ من البداية. هاي العملية شنو؟ أثناء ما يعني عملية البروسيسنج، المعالجة بالماشينة الرئيسية بالسورس دا تجري، بعد دا يعالج البيانات وهذا، شلون كأنما يعني تقدر تقول المعالج يحس بأنه راح يصير عليه لود أو راح يصير يعني مثل ما نقول ثقل عليه، فشي يسوي؟ يسوي بري كوبينج. شنو بري كوبينج؟ شو راح يسوي؟ راح ينسخ المعلومات المهمة نقدر نقول. أوكي، مثل البي سي بي، اوكي، اللي هو البروسيسنج كنترول بوكس، اوكي، ومعلومات اخرى مهمه ينسخها، اوكي، ويوديها وين؟ للوجهه، يعني الجهاز ثاني، اوكي، للديستنيشن، وما يقوم بعمليه شو اسمه عمليه المعالجه الى ان تخلص عمليه الاكسكيوشن، يعني عمليه مثل ما نقول التنفيذ اللي دا يصير البروسيسنج بهاي بالماكينه الرئيسيه. اوكي، ورا ما تخلص عمليه المعالجه بالماكينه الرئيسيه. اوكي، الديستنيشن اللي اخذنا لها نسخه مثل ما تقول من المعلومات مال الشيء اللي يريد نعالجه. اوكي، تبلش بعمليه المعالجه هناك. من تخلص هناك ترجع المعلومات للسورس. اوكي، وعلى اساسها ينطينا. طبعا اكو شغله مهمه انه شو اسمه، يعني يقول لك عمليه تنفيذ او هيك شيء. فمن تريد، شايف هاي مرات تطلع مثلا يقول لك ويتنج، مثلا تريد تسوي فد داونلود يقول لك ويتنج مثلا، او يقول لك ريدي. اوكي، هاي كلها هي بالبروسيسنج. يعني هو دا يقول لنا يابا مثلا من يصير عليه لود يقول لك ويتنج مثلا، انت شايفيها اكيد. فنفس الشيء هذا من يصير عليه لود، هاي مثلا شو اسمه، شو يقول ويتنج مثلا، او يقول ستوب على ما تنتقل معلوماته بالمشين الثانيه وتتنفذ، وترجع وراها يعطيك شو اسمه الريزولت مثل ما نقول. Yes, doctor. I think the idea is clear now.
Thank you. So I want to
Most
compare
welcome.
these two methods. I want to compare pre-copy and eager all. In eager all, we firstly stop the process on source machine, and then we transfer all the necessary data to the destination machine, and then we start the process on destination. Okay. But in pre-copy, while the process is under execution, we make a copy of the necessary information to the destination, and in one time we stop the process on source and immediately start the process on destination machine. Okay, translate it.
هسه شو يقول مثل ما يقول مقارنة بين النوع الأول اللي هو ايجل اول، ايجل أعتقد اسمها ايجل اول، والبري كوبي. أوكي، طبعا هسه أحكي شغلة أنا وهسه راح أوضحها أزيد. هو حكاها الأستاذ الظاهر ما لقيت عنده. على كل حال يقول لك بالطريقة الأولى بالايجل اول شو يسوي أول شيء؟ أول ما هذا شو يسوي ستوبنج لعملية المعالجة. وين؟ بالسورس. يوقف عملية المعالجة. وراها شو يسوي؟ ينقل كل المعلومات المهمة وين؟ للديستنيشن، للماكينة الثانية. اوكي، ورا ما ينقلهن ويخلص المعالجة بالريتيرن، يعني يخلص معالجة يرجعهن الماكينة الرئيسية، وش اسمه يسوي مثل ما يقول لك ريدي يعني او هيك شيء. بالبري كوبي شو يسوي؟ اول ما هذا شو يسوي نسخ للمعلومات المهمة. اول شيء ينسخن. هاي حتى عمليه تنفيذ، يعني عمليه البروسيسنج دا تمشي بالماكينه الاولى، بالماشين الاولى. اوكي، هاي الاثناء هو يسوي كوبي المعلومات الرئيسيه، وبنفس الوقت يرسلهن للديستنيشن. ورا ما يرسلهن للديستنيشن، يعني الوجهه مثل ما تقول او الماكينه الثانيه. اوكي، من يرسلهن لهناك شو يسوي؟ بعد وصلن هنا للديستنيشن ايش راح يسوي؟ راح يسوي ستوبينج علما للاكسكيوجن اللي موجوده بالسورس. يوقف عمليه المعالجه اللي هي بالماكينه الرئيسيه. ويمتى؟ ورا ما وصلت المعلومات الرئيسيه علما للديستنيشن، الماكينه الثانيه الوجهه. اوكي، اللي راح يسوي بها معالجه. من وصلهن بامان قبل وقف العمليه المعالجه اللي بالسورس. خلص هناك عالج شنو ما ادري شنو، ورجعهن للسورس. Clear, doctor? I hope it's
Oh,
so the information that I got it from you, I transfer it to the guys.
of course, it's okay. So the pre-copy has an advantage compared to eager all. The advantage is that the frozen time is very small. Why? Because while the process is under execution, we start to make a copy and to transfer the necessary data to the destination machine. So after we finish the transferring the data, we stop the process on source, and immediately we start the process on destination. The frozen time is very low. But in eager all, we firstly freeze, stop the process, and then we start to copy and transfer the data. So it is an advantage of pre-copy compared to eager all. Translate.
كلير دكتور كلير. أساتذة، فلذلك هسه بنظركم يا هو الأفضل، يا الطريقة الأولى لو الثانية؟ الأستاذ شو يقول؟ هو طبعا أكيد صحيح الطريقة الثانية أفضل. ليش؟ يقول لك لأن مثل ما تقول فريزنج تايم، يعني وقت مثل التوقف أو وقت التجميد مثل ما نقول بيها قليل، يعني مثل ما تقول المعالجة بيها تصير أسرع. ليش؟ لأن هو بالسورس بعد دا يعالج، هو قبل نسخ المعلومات الرئيسية بعدها حولها للديستنيشن، هو هذا بعد دا يعالج. أوكي، من نقلها لهناك سوى ستوب وعالج بالماكينة الثانية ورجع لنا النتيجة. أوكي، بينما بالطريقة الأولى اللي يقول أول شو اسمها، الطريقة الأولى شو يسوي؟ أول خطوة يسويها يوقف عملية المعالجة نهائيا. وقف عملية المعالجة. السلام ورحمة الله. وقف عملية المعالجة. أوكي، وراها نقل المعلومات للديستنيشن. أوكي، ورا ما نقل المعلومات للديستنيشن سوى المعالجة هناك وخلص وش اسمه، والريزولت رجع لمن؟ شو اسمه، للسورس. فلذلك الطريقة الثانية أفضل من الطريقة الأولى.
And also, pre-copy has a disadvantage. What is the disadvantage? It is about consistency. Suppose the process is under execution on source machine. We start to make a copy while the process is under execution. While the process is under execution, some data may be changed. So some copied data may be changed. So we have to repeat the copy to the destination. It is the disadvantage of pre-copy. If you understand, translate. If you do not understand, tell me to explain more.
Doctor, what I understood it is that mean some information it will be, that mean not will be a two copy of it. No, it's some of them maybe it's not updated, we can say.
Yes.
Or not send it to the.
Yes.
So after that,
when we are making a copy, the process is under execution. Okay. Some local variables, the value of variables changes. Okay, suppose some local variables change the value. Okay, so we have to again copy the new data to the destination. It's the disadvantage.
clear دكتور. أساتذة، ورا ما عرفنا الادفانتج مال البري كوبي، اوكي، قلنا انه وقت تنفيذها قصير يعني اسرع. اوكي، عندها شنو بعد؟ عندها ديس ادفانتج. شنو الديس ادفانتج مالتها؟ انه يقول لك اثناء، باعتبار انه البري كوبي النسخ يصير اثناء التنفيذ، يعني البروسيسنج دا يتنفذ بالسورس ويصير ويسوي نسخ وينقل هاي المعلومات للديستنيشن وهناك يعالجها. باثناء هاي العمليه احتمال يصير تغيير بالبيانات. اوكي، مثلا على سبيل الارقام او فد شيء، يعني يصير تغيير بالبيانات. اوكي، فمن يرجعها شو راح يصير؟ راح يسموه consequence، يعني شلون اكو معلومات نقدر نقول ناقصه او مو كامله، هيك شيء ماكو. فشو يحتاج هذه المعلومات اللي تغيرت، اوكي، لازم مرة ثانية تنسخ وترسل شو اسمه للديستنيشن حتى تصير عملية المعالجة مالتها وترجع. بس هذه مو دائما تصير، قليلة، فلذلك يعني كديس ادفانتج. كلير دكتور.
Very good. And the other method is called eager dirty. Eager dirty is another method. In the previous method, pre-copy, we make a copy of all things of the process. That is, all things in the main memory and external memory. You know, some information of the process and programs that are under execution are in main memory, and some others are stored in disk, virtual memory. It is called virtual memory, pages on disk. So in previous methods, we transfer all the data, those which are in main memory and those which are stored on disk. But in eager-dirty, we move all things from main memory, only main memory. In eager-dirty, we transfer only that portion of the address space that is in main memory, and it is good because we do not transfer all the data stored on disk, so communication may be light. And if the process on the destination machine, on the target machine, needs some data that is stored on the disk of the source machine, it can refer it, it can request to access it. So it can be bad if we have a large data access from the process on destination machine. Understand?
In fact, Doctor, I didn't like it because from the name of it is dirty, so this is the first thing. But Doctor, is that mean the address space will be two copy or not two copy, but it will be saved at the main memory and at the disk memory?
Listen to me. When a process is in operating system is under execution, it has some data. For example, PCB flags, local variables, and many other things. Some of these data is stored on main memory, on RAM, but some of others may be stored on hard disk. So in eager-dirty, we only transfer that portion of the address space that is in main memory. We do not transfer the information and the data that is stored on hard disk. That is why we say eager-dirty here. That's it. You can translate if you understand, if you have understood.
Yes. Yeah. So, Doctor, I can't hear anything. I don't know if you hear me.
Mr. Zioti, can you hear me?
Can you hear me,
Mr.
Doctor?
Zioti,
Sorry.
I hear too, okay?
Can you
I
hear me,
said,
Doctor? Now I hear you, yes.
okay, I'll repeat it again. In the previous
Yeah, I can hear
methods,
you now, Doctor, but I don't know if
in
you
the previous
hear.
methods, pre-copy and eager all, we transfer all the data
Thank you, Adam.
of the process. The data of the process is stored in main memory, and part of the data may be stored in hard disk. Okay, in previous methods we transferred all the data, those which is stored on main memory and those which is stored on hard disk. But in eager-dirty, in this method, we transfer only that portion of the address space that is in main memory. That's it.
Mm-hmm. Mm-hmm. Clear, Doctor. أساتذة هذه الطريقة الثالثة اللي هي ايجر ديرتي، هذه شنو اختلافها عن الطريقة الأولى اللي هي ذيك ايجر اول؟ هذه الطريقة ذيك من اسمها اول يعني كل شيء، كل المعلومات تنقلها. هذه مو كل المعلومات تنقلها. ليش؟ شنو المعلومات؟ المعلومات وين مخزونة؟ اما متخزنة على المين ميموري. اوكي، مو اما وانما هي متخزنة على المين ميموري وعلى الهارد ديسك. اوكي، بالطريقة الاولى الايرور اول ينقلهن كلهن اللي على المين ميموري واللي موجودات بالهارد ديسك كلهن ينقلهن للوجهة الثانية، يسوي معالجة يرجعها. بهاي الطريقة شو ينقل فقط المعلومات الموجودة بالمين ميموري. على سبيل المثال البي سي بي اللي هي شو اسمه اللي البروسيس كنترول بوكس. اوكي، والمعلومات الاخرى اللي موجودة على المين ميموري وين ينقلهن للوجهة الثانية. اوكي، يسوي معالجة ويرجعهن. مرات شنو؟ مرات انه يحتاج معلومات اخرى ما موجودة على المين ميموري، وين موجودة؟ على الهارد ديسك. فشي يسوي شو اسمه الديستنيشن يعني الماكينة الثانية شو يسوي ريكوست اوكي للسورس، يقول له يابا انا اريد المعلومات اللي موجودة على الهارد ديسك، بعض المعلومات اللي موجودة على الهارد ديسك، فياخذ المعلومات ويرسلوا له شو اسمه
It is
ترسل له
good
المعلومات
because we do not
الديستنيشن،
transfer all the data
يكمل المعالجة
stored on
ويرجعها
this.
مرة ثانية.
So communication
Yes,
may be
doctor.
light. It is good. But it is not good because both the source and destination machines are working at the same time for running the process, because we have a portion of data stored on the disk of the source machine. So the source machine is working with the destination machine to run the process. Both machines must be working. That's it.
فلذلك أساتذة شو يقول الأستاذ؟ يقول إنه هذه الطريقة بها مثل ما تقول يعني أدفانتج نقدر نقول الأدفانتج مالتها إنه أسرع، نقدر نقول أسرع بالتنفيذ، لايتر أخف نقدر نقول، أو أسرع بالتنفيذ. ليش؟ لأن هو راح ياخذ مو كل المعلومات، فقط اللي موجودة على المين ميموري وينقلها هناك المعالجة. أوكي، بس الديس أدفانتج مالتها إنه شنو؟ إنه السورس والديستنيشن اثنيناتهم راح يكونون يشتغلون نفس الوقت. ليش؟ لأن السورس دا يشتغل على المعلومات اللي موجودة على الهارد ديسك، أوكي، يعالج بيها، والديستنيشن يعني الماكينة الثانية دا يشتغل على المعلومات اللي موجودة على المين ميموري. أوكي، هاي نقدر نقول عليها جزء أدفانتج مالته. جزء
Copy on reference. Copy on reference. In this method, everything is on demand. Everything is on demand. In the previous method, the stored data on the disk on source machine was on demand. It means we do not transfer the stored information on the disk in the previous method. But in this method, copy on reference, everything is on demand. We do not transfer process data from the source machine to the destination. We do not transfer the data from the source machine to the destination. It means the data in the main memory and the data stored on hard disk will be on the source machine, and the reference is on demand from the destination. So we only create the process on destination, but the data the process needs is stored and is available on source machine. That is why we say copy on reference. Pages are only brought over on reference. Then, when the process on the destination needs some data, it can access to the data on source machine. That's it.
Sorry, Doctor, can you repeat because the internet is going on and come back again. Sorry.
Do you want me to repeat?
We can say that, yes, because a lot of information I didn't hear it.
I can't hear you.
Yes,
Do you want me to repeat?
yes, doctor, if you can, please, because a lot of information that I didn't hear it. If you can repeat it, thank you a lot.
I can't hear you. Mr. Ziauddin.
Sorry, doctor, can you hear me, please? In fact, the internet is, we can say it's a bad connection of internet.
Unfortunately,
So please,
I can't hear you.
if you can hear me, if you
Other students,
can repeat
other
the
students,
information
can
that
you hear Mr.
said.
Ziauddin? I repeat it again, okay? Copy and reference. It is the other method of migration. In this method, everything is on demand. We do not transfer process data from the source machine to the destination. So the source data, the process data, will remain on the main memory and the hard disk of the source machine. We do not transfer the data of the process. We only create a process on the destination machine and execute it. So all the data is left on source and we only create the process on the destination. Then when the process on the destination machine needs some data, it can access to the data on source machine. That's it.
In fact, doctor, I didn't understand because if nothing will be transferred to the destination, so what is the idea of the processing there? If you hear me, doctor. That means what is the reason of creating a processing there if nothing will transfer it to the
when our
resource
process is responsible to calculate something and it doesn't need any heavy access to the data. It is light. It is for calculating and computing something. We can only create the process on the destination, and and all the data is left on source machine. However, if the process needs some data, it can access to the source machine to access to the data. It is called copy and reference. Got it?
In fact, doctor, no, because I didn't can say understood the idea. That's doctor, sorry. That means if all the information will be stay at the source, so at the destination, why we create a processing there and all the information here? So why we create that means processing there?
I said, suppose your process is a program that calculates something, okay? I said that the process is a program that is under execution. It's a program, it's a code, okay? If we have a code to execute something, it's a function, for example, to execute something, okay? And it doesn't need a huge data. For example, it doesn't have many local variables, for example, okay? So the PCB is light and the variables is very light. For example, it's for calculating something. We only create the process on the destination and we do not transfer the PCB and local variables and other process data to the destination. That's it.
Okay, doctor. أساتذة هاي الطريقة الرابعة طبعا يعني حاولت إن الأستاذ يعني يعيد لي إياها أكثر من مرة لأن الفكرة ما كملت عندي حقيقة، يعني من باقي شرحها بس بعدين نحاول نطلع عليها ونشوف. شو يقول الأستاذ؟ يقول هاي الطريقة الرابعة نقدر نقول عليها هي الكوبي أون ريفرنس. هاي الطريقة شنو؟ يقول لك هاي تختلف عن البقية إنه ما تنسخ أي شيء أو ما تنقل أي شيء لا من المعلومات اللي موجودة على الميموري ولا المعلومات الموجودة على الهارد ديسك، كلهن يبقن وين يبقن بالسورس. اوكي بس شو يسوي؟ الظاهر يعني الظاهر انه يعطي فد معلومة شو اسمه للديستنيشن للماكينة الثانية، يقول له يا بسوي بروسيسنج، سوي معالجة. اوكي يسوي معالجة. هسه شو يقول؟ انا قلت له ليش دا تسوي معالجة هناك هو كل شيء منقول يعني من السورس. يقول انه احسب يعني او خلي يعني على سبيل المثال عملية حسابية بسيطة. اوكي فما تحتاج تنقلها اي شيء، يعني مجرد معلومات بسيطة تقدر تقول او فد شيء خفيف مثل ما تقول تنقل هناك. اوكي او يعني فد شيء بسيط هناك، يعني حسابات مثلا على سبيل المثال فد فاكشن او فد شيء هناك تصير او المعالجة وترجع النتيجة من هناك اسمه للسورس. اوكي دكتور.
And lastly, flash.
Doctor, do you hear me?
Yes, yes. Can you hear me too? Can you hear me? Okay.
Yes, now. Yeah, now.
The last method of migration is called flashing. Flashing. In this method, we flash all the data from main memory to disk on source machine. So we firstly flash and move all the data from main memory to disk on source machine, and then we act as copy on reference, the previous strategy. That means that is, we do not transfer data to the destination. We store all things all on disk of the source machine, and then we create process on destination. The process on destination can then access to the disk of the source if it needs. Clear? Clear?
Sorry, Doctor, do you please? Can you hear me, Doctor? Sorry.
Yeah, I repeat. Okay.
Yes, please. Sorry, because you know in Iraq is little the internet is not good enough.
Don't worry, no problem. Okay. In this method, flashing. In this method, we flash all the data from main memory to disk on source machine. Okay. The process is under execution on the source machine. We flash, we transfer all the data from main memory to disk. We store to the disk, okay? And then we act as copy on reference strategy, the previous method, copy on reference. That is, we do not transfer data to the destination. We store all things on the disk of the source machine, and then we create process on destination. The process on destination can then access to the disk of the source if it needs data. That's it.
Clear, Doctor. Clear. أساتذة هاي الطريقة الأخيرة اللي هي فلاشنج. هاي الطريقة شو تسوي؟ بما أن نعرف أنه أكو معلومات على المين ميموري وأكو معلومات على الهارد ديسك، هاي شو تسوي؟ تسوي فلاشنج لكل المعلومات اللي موجودة على المين ميموري. وين تنقلها؟ ننقلها للهارد ديسك. أوكي؟ ورا ما تنقلها للهارد ديسك ماكو داعي تنقلها تبقيها بالسورس، بس تنقلها للهارد ديسك فقط. يعني تنقل المعلومات اللي موجودة على المين ميموري تسويها فلاشنج، يعني كأنما تمسحها أو تدفعها كلها، تنقلها وين؟ للهارد ديسك. ورا ما تنقلها للهارد ديسك تبقيها وما تسويها، يعني ما تنقلها المن لل destination ماشين. اوكي شو يسوي بعد؟ بالديستنيشن ماشين يسوي عملية البروسيسنج، وإذا هناك بالبروسيسنج يحتاج أي معلومات حتى يكمل البروسيسنج اوكي، يسوي ريكوست هماتا للسورس حتى يدخل وين؟ يسوي اكسس للهارد ديسك اللي موجود على السورس، ياخذ المعلومات اللي يريدها. Yes, doctor, clear. Doctor?
Okay, finished? Finished, Mr. Ziauddin?
أساتذة إذا سمعوني يعني ما أعرف يعني عندي نقطة حمراء. Yes, doctor, now I hear you.
Have you
Yeah,
finished
I
translation?
But I don't know if they hear me because the internet was not good enough.
I can't hear you correctly.
Yes, doctor, I finished.
I can't hear you correctly. Have you finished the translation? Okay.
Yes, doctor, I finished.
So we can finish this session here, and we can continue our discussion next session about negotiation of process migration steps, and other things. Okay. It's very important lecture. Please take enough time to study it and to understand it completely. And I again thank Mr. Ziauddin for translating. I hope you have a good night here tonight, and
So glad to it's glad to me, doctor, to talk with you and to explain this information to my friends.
You're welcome.
Thanks a lot for your cooperation, doctor.
Have a good time. Have a good night, and Khuda Hafiz.